Today's our topic is Compton Effect. This topic is little bit lengthy, so we will complete it in two parts. So first part is in this video and another part will be in another video. So let us talk about the Compton Effect and put the heading Compton Effect. Compton Effect. So this effect was given by, or it was observed first by Professor Compton in 1923. It was first observed by Professor Compton in 1923, and he observed that when a photon of high energy is incident on light element, then photon is scattered with modified frequency as well as with unmodified frequency, and also we get some recoil electrons. So this phenomena is termed as Compton effect. So let us write it in short. when high energy when high energy photon is incident on light element on light element is scattered photon has frequency modified and unmodified together recoil electron with recoil electron. So this phenomena is termed as Compton effect. Now here the frequency which is modified in comparison to the original frequency of the incident photon. So let us say the frequency of incident photon frequency of incident photon is new. Then the modified frequency of scattered photon is, let us say, nu dash. Then in Compton effect it is observed that nu dash is always less than nu or equal to nu. Nu dash may be equal to nu. If it is equal to nu, it means it is unmodified frequency or unmodified photon, and if nu dash is less than nu means it is modified photon. In never we observe the cases such that nu dash is greater than nu. This cannot be observed. In Compton effect, always the modified frequency is less than or equal to the original frequency. So this effect is termed as Compton effect. Now it is also observed that this frequency does not depend on the change in frequency does not depend on the original frequency, and also the change in frequency or the difference in frequency is it depends on the angle of scattering. It depends on the angle of scattering. So in this case it is also assumed that the electron is free. So when photons are incident on light element, then we assume that the electrons are free in the element. Electrons are free in the element. Free in the element. So it is like the collision phenomena. It is like the collision problem between a photon and electron. So we can solve this problem as the collision between photon 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 and a free electron. So mathematically we will solve this problem as collision between photon and a free electron. Now if the electron is not free, if electron is not free and it is bound to the element or atom, it is bound to the atom, it is bound to the atom. In such case, some of the energy of photon may go in unbounding the electron, in unbounding the electron to get free electron, free electron. Now because the in Compton effect, the energy of incident photon is very large, therefore the energy spent in unbounding the electron in the light element is very small in comparison to its original energy. So we can neglect this energy which is spent in unbounding the electron and to get a free electron. So practically we assume that whenever a high energy photon is incident on a light element, then it is the problem like the collision between photon and a free electron. So now we will treat this problem as a collision between photon and free electron. So let us go to another page. So now what are our objectives in this lecture? So means what we are going to calculate. So first, so our objectives are, the first thing, that proof of nu dash is less than nu or equal to nu. So we have to prove that when there is collision between a photon and a free electron, then the scattered photon has frequency less than or equal to the original frequency. This we have to prove, and then we will find the difference between nu dash minus nu, means the difference between the modified and unmodified frequency, and then we will find the lambda dash minus lambda, means the difference between the wavelength and original wavelength. So here it is, I have written nu dash minus nu, but this can be written as nu minus nu dash because nu is large in comparison to nu dash, and because the frequency of a modified photon is large, therefore the is small in comparison to original frequency, therefore the wavelength of the modified photon is large in comparison to original wavelength. So we will calculate this difference which is termed as delta, and this is also known as Compton shift. Compton shift. And then the facts about Compton effect. Compton effect. So in this lecture, as I said earlier, that this topic is little bit lengthy, therefore I have divided the topics in two parts, and in this lecture we will discuss these points, that is the proof of that nu dash is less than nu and all these points, and in another part which will be termed as Compton effect part 2, we will discuss the rest of the thing about the topic. So let us start this. So as I already said that the problem is like the collision. It is like the collision, elastic collision between photon and electron, free electron. So here we are treating the electron as a free electron. So let us make a diagram. Suppose this is the line of action. This is the line of action in the x direction. So a photon is coming like this, and there is a free electron. There is a free electron, and then after scattering, the photon is going in this direction, and let us say the electron is going into another direction. So this is the photon, and here it is the electron. This is electron. So this is incident photon. So let us write here incident photon. Incident photon. And this is the scattered photon. Scattered photon. And here it is the recoil electron. Recoil electron. And this is the direction of the motion. So let us write this as the angle phi, scattering angle, and this is the angle theta. So phi means phi is the scattering angle. Phi is termed as scattering angle, and theta is the recoil angle. Recoil angle is theta. So for the incident photon, the frequency is nu, original frequency is nu. So here the energy is h nu, and here for the scattered photon it is h nu dash, and here it is the recoil electron. So this recoil electron has the velocity v, let us say, and the mass m. So it is mv. Mv is the momentum. Mv is the momentum of the recoil electron. Now, keeping this picture in mind, let us go to the next page. So now we can write that what are the values of the energy and the momentum. So let us recall the problem of collision, in which we write the equation for the energy of conservation, and also we write the equation for the conservation of linear momentum. So what are the conditions before collision? Before collision. And what are the values after collision? After collision. So let us list all these values. So first is the energy of photon. Energy of photon. So before collision, the energy of photon is h nu, and after collision this energy is h nu dash. Then the momentum of photon. Momentum of photon. Now the photon has rest mass 0. So if we write the formula of momentum as m into v, then this momentum will become 0. So in the case of photon, the momentum is given by E by C. So it is h nu by C. It is h nu by C. And here the momentum is h nu dash by C. Then come to the energy of electron. Free electron. Energy of electron. So we have assumed that the free electron is at rest. So let us assume that free electron is at rest. Therefore, it has zero velocity initially, and the total energy which is contained in the electron, it is the rest mass energy. And rest mass energy means it is m naught c square. Mc square, where m naught is the rest mass of the electron. M naught c square. And here the energy will be mc square, because now the electron is in motion. it is no more in the rest. Before collision or at the time of collision, we have assumed that electron is at rest, but now we are saying that electron is not at the rest, because it will also move and it will gain certain velocity v, so the mass will also change. This is the relativistic effect. Therefore the rest mass is m naught, but when it gains some velocity, some high velocity, then mass also changes with the velocity. This is the relativistic effect. So now it is mc square. And then momentum of the electron. Momentum of electron. So momentum is here 0, because m into v, and v is 0, means we are treating the electron as at the rest initially at the time of collision. Therefore the momentum is 0, but after the collision the momentum is m into v. The momentum is mv. So using all these values, we will write the equation for the conservation of energy. Equation for the conservation of energy. So equation of conservation of energy means the energy before collision is equal to the energy after collision. So let us write this, and before writing this I have to write one more equation, and that equation is the relation between m and m naught. So let us write it here. So there is relation that m is equal to m naught upon under root 1 minus v square by c square. So when the velocity of the any particle or any object approaches to the velocity of c, where c is the speed of light, then the mass is not constant, but it also increases with the increase in the velocity, and this is the relation. So where m naught is the rest mass, so if we put v is equal to 0, then m is equal to m naught, and if v is close to c or it is equal to c, then it will become infinite. So the mass is increasing continuously with the increase in velocity. See, this is the relativistic effect. So this relation we will use later on. Now come again to the conservation of energy. So means the energy before collision is equal to energy after collision. So let us write it. So h nu plus m naught c square is equal to h nu dash plus mc square. Now this is equation number 1, and this is equation number 2. Equation number 2. Then we will write the equation for the conservation of linear momentum in both the direction, in the x direction as well as in the y direction. So conservation of linear momentum. Conservation of linear momentum in x direction and in y direction. So in x direction, let us write and recall the previous figure. So in previous figure, in x direction, the initial momentum was h nu by c, and then the 0 for the electron, and this is equal to h nu dash by c into cos phi plus mv into cos theta. So this is the conservation of linear momentum in x direction, and similarly write another equation in the y direction. So again recall the picture which I have drawn. So in that case there is no motion of any particle in the y direction initially. So the initial momentum of the photon in y direction is 0. The initial momentum of the electron in y direction is 0. And now after collision it will be h nu dash by c into sin phi minus mv into sin theta. So this is equation number 3, and then equation number 4. Now let us do some manipulation here and write these two as mv cos theta. Mv cos theta is equal to h by c nu minus nu dash cos phi. or this can also be written as mvc cos theta is equal to, I have multiplied c here, is equal to h into nu minus nu dash cos phi, and in another equation it is mv sin theta. mv sin theta is equal to h by c nu dash sin phi, or on the same basis it can be written as mvc sin theta is equal to h nu dash sin phi. So now let us term these equation as equation number 5 and equation number 6. Now what we have to do, we have to take the square of both equation and then add, means squaring equation number 5 and 6 and then add both the equation. Then we will get m square v square c square cos square theta and sin square theta, and we know that cos square theta plus sin square theta is equal to 1. So I am writing it as m square v square c square is equal to, and here it will be h square and nu minus nu dash cos phi whole square. So it will be nu square plus nu dash square cos square phi minus 2 nu dash cos phi, and then plus h square nu dash square and sin square phi. So this is the equation, and when we will add these two terms, then again we see that here it is nu dash, here it is nu dash square cos square phi, and it is nu dash square sin square phi. So collecting these two terms, again we will get 1. So let us go to the next page. And then we will have the term like it is m square v square c square. So let me check the equation. It is m square v square c square is equal to h square, and within bracket we have nu square plus nu dash square minus 2 nu dash cos phi, and this is equation number 7. Now we will do some manipulation, and let us take the square of equation 2, square of equation 2. So go to the equation 2, and what was that equation? Equation 2 was h nu, means the conservation of energy, h nu plus m naught c square is equal to h nu dash plus mc square. This was the equation. So first I will write this equation as mc square is equal to h nu minus nu dash plus m naught c square. So let us first write this equation as, this was equation number 2, mc square is equal to m naught c square plus h nu minus nu dash, and then square this whole equation. So we will get m square c to the power 4 is equal to h square, and then nu square plus nu dash square minus 2 nu dash plus m naught square c to the power 4, and then plus 2h nu minus nu dash into m naught c square. This is the equation. Yes, and this is equation number 8. Now subtract equation number 7 from equation number 8. So equation 8 minus equation 7. So let us subtract it. So what will happen? It will be m square c to the power 4 minus m square v square c square is equal to h square and then nu square plus, here let us see that it is nu square plus nu dash square, and here again we have nu square plus nu dash square, so these two will get cancelled, and then we are left with uh, this minus, and then minus will become plus. So here we will have h square, and then 2 nu dash inside the bracket, and then it will be cos phi minus 1. So this will be termed, this term and this term will give this factor, and then plus m naught square c to the power 4 plus 2h nu minus nu dash into m naught c square. So now let us first solve this portion. Let us solve this portion first by substituting the value of m square in terms of m naught. So we can take here m square c square common, and within bracket we will have c square minus v square, and this is equal to same. So first I am solving only this side, and then it will be, instead of m square we will substitute m naught square upon 1 minus v square by c square, and then of course there is c square, and here it is c square minus v square. So it is c square minus v square here, and c square will go in the numerator, so it will become m naught square c to the power 4, and then divided by c square minus v square, and here within bracket we have c square minus v square. So this c square minus v square get cancelled with each other, and we are left with only m naught square c to the power 4. So our left hand side is m naught square c to the power 4. Now we have to solve this also little bit. So what we see now, that here we have term m naught square c to the power 4, and here also we have term m naught square c to the power 4. So it will get cancelled with each other, and then I am writing here the rest of the term. This m naught c square 4, m naught square c power 4 is equal to all these terms, and so m naught square c to power 4 get cancelled with this term, and we are left with here on the left hand side it will be 0, and on the right hand side it will be the first term and the second term. So now this will be like 2h nu minus nu dash into m naught c square, this term is equal to minus of this term, because we will transfer this term on the left hand side. So this cos phi minus 1 will now become 1 minus cos phi, and then we can write it as 2h square nu dash into 1 minus cos phi, 1 minus cos phi. So again 2h get cancelled, and then we are left with some other formula. So let us write it as nu minus nu dash divided by nu dash, nu dash, and then it will be equal to h upon m naught c square, h upon m naught c square into 1 minus cos phi, 1 minus cos phi. Now let us divide this by nu dash. So nu upon nu dash means 1 upon nu dash minus 1 upon nu. This is equal to h upon m naught c square into 1 minus cos phi. So our first objective was to find out the relation between the nu dash minus nu. So here it is the relation of 1 by nu dash minus 1 by nu. So now let us inspect into this, what will be the value of this difference. So if we put cos phi, the value of cos phi, we know that the minimum value of cos phi is minus 1 and the maximum value of cos phi is plus 1. So it ranges between minus 1 and plus 1. So let us put the minimum value. So if we put cos phi as minus 1, then what will happen? Now let us put first as plus 1. Let us first put it as plus 1. So if cos phi is plus 1, then it will be 0, means 1 by nu dash minus 1 by nu is equal to 0 for cos phi is equal to plus 1. And now if we put cos phi is equal to minus 1, then what will happen? This 1 by nu dash minus 1 by nu is equal to 2h upon m naught c square. So this is again a positive value. So what we see here, we see that this factor 1 by nu dash minus 1 by nu is in all the cases will be greater than or equal to 0, means this is a positive term, this will be a positive term. So now let us go to the next page and write it again, the previous equation, and it was 1 by nu dash minus 1 by nu, and that was equal to h upon m naught c square. Let me check this. Yes, it is right. H upon m naught c square into 1 minus cos phi. This was the term 1 minus cos phi. And then I said that in all the cases, whatever be the value of cos phi, this difference is always positive. It will be 0 or greater than 0. So now we can write it as 1 by nu dash minus 1 by nu is always greater than equal to 0. And because this is the reciprocal, therefore if we take the reciprocal of this, then we can write that nu dash minus nu is always less than equal to 0. So what does it imply? It implies that nu dash is less than or equal to 0. Equal nu, not 0. Nu dash is always less than or equal to nu. So in the case when nu dash is less than nu, means it is the modified frequency. So this is the Compton effect. Let us go into the definition of quantum effect. That in the Compton effect we get the modified frequency as less than the frequency of the original frequency of photon. So now nu dash, which is modified frequency, is always less than the original frequency, or at the most in the unmodified case. In unmodified case, both frequencies are equal, so nu dash is equal to nu in unmodified case. So this is the thing which we wanted to prove. And now let us derive the similar things with the lambda. So let us start with the lambda wavelength. So now put the value in terms of lambda. We have the relation that nu into lambda is equal to c. So 1 upon nu will be lambda by c. So now let us substitute this relation in this equation. So what we will going to get, it will be lambda dash upon c minus lambda upon c is equal to h upon m naught c square into 1 minus cos phi. 1 minus cos phi, and this c can be taken common, so it will be lambda dash minus lambda, and this c get cancelled with 1 c, so it will be h upon m naught c into 1 minus cos phi. So this is the relation. So again we see that this is a positive factor, as already the same factor, this is a positive value or the 0 or positive, so we can write lambda dash minus lambda is always greater than equal to 0. So in the case of frequency, the modified frequency has the value less than the original frequency, but in case of the wavelength, the modified wavelength lambda dash has the wavelength greater than the original wavelength. So this shift lambda dash minus lambda is termed as delta, and this is known as Compton shift. This is known as Compton shift. Compton shift. Now let us calculate the value of Compton shift. So it depends on the scattering angle. So we can see easily that it depends on the lambda depends on the scattering angle. Phi is termed as a scattering angle. So what will be the value of delta? Let us find out with the value of phi. So if phi is 0, If phi is 0, so cos 0 means 1, so it is 0, means in the same direction, in the x direction. When phi is 0 means we are looking in the x direction. uh, then there is no change in the wavelength, means we will see the unmodified photon with the original wavelength of lambda. Now when phi is equal to 90 degree, 90 degree, so cos 90 degree means 0, and then this value is h upon m naught c, h upon m naught c. Now this h upon m naught c is known as the Compton wavelength. This is known as Compton wavelength. Compton wavelength. Compton wavelength. H upon m naught c is termed as Compton wavelength. You can see that all the factors are constant. H is Planck constant, m naught is the rest mass of the electron which is constant, and c is the speed of light. This is also constant. So all these constant values are a constant term. Therefore, we can calculate this term, and this term is 0.0242 angstrom. So Compton wavelength is 0.0242 angstrom. Now if we put phi is equal to 180 degree in the backward direction, then in cos pi is equal to minus 1, so minus minus plus 1, 2. So this will be 2h upon m naught c. Delta, the Compton shift is 2h upon m naught c. So the value of 2h upon m naught c will be double of this, which is 0.484 angstrom. 0.0484 angstrom. So what we have found here, we have proved the first objective, that nu dash is less than nu, and then we have calculated the Compton value of Compton shift. Value of Compton shift is 0.0242, which is the Compton wavelength at 90 degree. Now let us go to the next page and discuss some facts about the Compton effect. So put the heading facts about Compton effect. About Compton effect. The first thing is that uh, the modified frequency, the modified frequency is always less than the original frequency, is always less than the original frequency, original frequency of photon, of photon. This fact is also very obvious because we are giving some energy h nu as the original energy of the original photon, and because the photon will gives it some part of energy during collision to the electron, therefore it will have less amount of energy in the scattered photon, and therefore always the energy of the scattered photon will be less than the original incident energy of the photon. And because the frequency is directly proportional to the energy, therefore it is obvious that the modified frequency is always less than the original frequency of photon. Then the next is that the Compton shift. Compton shift is independent of original wavelength. Original wavelength or original frequency. Original wavelength or original frequency. So So now let us recall the term lambda dash minus lambda, which is equal to delta, which is Compton shift, and this is h upon m naught c into 1 minus cos phi, 1 minus cos phi. So here we can see that this delta doesn't depend on the lambda. It doesn't depend on the original lambda or the original frequency. So the shift is independent of the original lambda or original frequency. And then third point is that Compton shift, Compton shift depends on scattering angle, depends on scattering angle phi. So this is obvious in this equation because it is depending on the cos phi, and phi means it is the scattering angle or scattered angle. So it doesn't depend, the delta lambda dash minus lambda doesn't depend on the original lambda, but it depends on the angle of scattering. And this we have already seen in the previous slide or in the previous page, that if theta is equal to if theta is equal to 0, then delta is equal to cos 0 means 1, delta is equal to 0 means we are getting the unmodified photon, and if theta is equal to 90 degree, then it is delta is equal to cos 90 means 0, so it will be h upon m naught c, and the value is 0.0242 angstrom. And if theta is equal to 180 degree, 180 degree, then delta is equal to 2h upon m naught c, which is equal to 0.0484 angstrom. Now this value, which is termed as the Compton wavelength, this is termed as Compton wavelength, Compton wavelength. This value 0.0242 angstrom is only 0.001% of the wavelength of visible light. Visible light. So what is the range of the wavelength of visible light? It is 4000 angstrom to 7000 angstrom. This is the range of the wavelength for the visible light. So if we see the percentage of 0.0242 angstrom with in comparison to 4000 angstrom, we find that it is only 0.001%. So this is very small value if we incident the visible light and treat it as Compton effect. Means, let us recall the definition of the Compton effect, which I said earlier, that it is the incidence of the high energy photon. When high energy photon is incident on light element, then we observe the Compton effect. Now if we incident the low energy photon on the light element, then there may be some scattering process, but the change in the wavelength is very small because it is only 0.001% of the original wavelength lambda of the visible light, which is 4000 angstrom nearly. So we cannot observe it experimentally. So it is difficult to observe, and we cannot say that some effect has been done. But if we use X-ray, if you use high energy photon, high energy photon, high energy photon means it is the X-ray or gamma ray. So these X-ray and gamma ray photons have high energy, and the wavelength is approximately 1 angstrom. So if we take the value of 0.0242 angstrom in comparison to 1 angstrom, then it is 2.42%. It is 2.42% of the 1 angstrom. So 2.42% is uh, easy to observe experimentally. 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 So it is said that Compton effect is observed when high energy photons are incident on the light element. So high energy photon have the measurable amount of the Compton shift, which is only 2.42, which is 2.42% of the original wavelength. Whereas if we apply or if we incident low energy photon, for example the visible light, then it is only Compton shift is only 0.001% of the original wavelength, which is not easy to observe. So this is all which I wanted to discuss in this lecture, and in the next lecture we will discuss some other topics of the Compton effect, like the is angle of the recoil electron, or recoil angle of the electron, which is theta. So we have to find out the value of theta, and then what will be the kinetic energy of the recoil electron. So these two things we will discuss in the next lecture or in the next video, and also the experimental verification of the Compton effect. So this will be the third point, and then the difference between the photoelectric effect and Compton effect, because we have already discussed the photoelectric effect. And in the photoelectric effect I said that photon is either it is absorbed totally or it is not. But here in the Compton effect we are seeing that the photon is, some part of the energy of photon is absorbed, but rest of the part is carried with the photon. But in the case of photoelectric effect, the photon totally disappears and the total energy is transferred to the ejected electron. So there is a difference between the photoelectric effect and Compton effect. So this again we will discuss in the next video. So let us stop here.